Welcome. This is Ted Cole again, starting my series on Reconstructing Gravity. Now, for those who've been following me, this is a follow-up to my series called Reconstructing Relativity, in which I looked at special relativity. And I extended that work into considerations of gravity. And so this is just going to be an introductory video, basically asking the question, what is gravity? How does it work? And can we come up with some physical explanation for how it works based on the constructive model that was developed for special relativity? Remember, Einstein developed his special relativity theory without a constructive model. And then that led to a space-time model of special relativity, which was more abstract. And then he expanded that to consider gravity through his general relativity theory, which was way more, even much more abstract than his special relativity theory. Now, as we know, Isaac Newton developed his gravity theory in the late 1600s, and he conceived of gravity as a force between masses. And that force is a constant called big G times the product of the two masses, the large M usually representing a planet and the small m a mass attracted to that planet, but they're actually force acts on both bodies. But G times big M times little m over r squared, where r is the distance between the centers of mass of the two masses. But totally unexplained, of course, was the reason for this force. And it was just a mysterious force that acts at a distance with no explanation really of how or why that happens. And Einstein, remember his special relativity theory came out in 1905. General relativity roughly a decade later, and it was an expansion of the special relativity space-time model in a way that included and defined gravitational attraction. The math was a purely mathematical model, very complex, very abstract, tensor mathematics, which is like you got vectors and you got tensors, or sort of multi-dimensional vectors. And one of the phrases that comes out of it is mass tells space-time how to curve and space-time tells mass how to move. That's one way to encapsulate it. Although to me still there's a little bit of a mystery as to exactly how that works. But well, that's what I'm going to try to get at a little better as to what physically is going on, because Einstein's model is completely mathematical, and we're going to take a different approach and try to look at something physical that causes gravity. The briefest description of what I'm going to try to do here is to use the constructive model that we used for special relativity to look for physical mechanisms that might be involved in gravitational attraction. And, what causes a ball to drop when it's dropped? And ultimately, what causes gravity to exist in the first place? Is there some reason that it's there? I mean, it exists clearly, but why? How did that start? The main topics I'll be looking at, perhaps in this order, I'm not sure yet. How does gravity accelerate a mass? How does gravity cause time to slow down? There's gravitational time dilation effect. What's up behind that? Why is a gravitational mass and inertial mass always proportional? I have a model of bending of starlight, similar to what Einstein did, only a completely different way, using a constructive model and Euclidean geometry instead of the extremely complex Riemannian mathematics, Riemannian geometry that he used. And there's another experiment that was done to affirm Einstein's general relativity called the Shapiro delay experiment. So I do a calculation on that also. And then, like I said before, what is the root cause of gravity? How does it come to be, and why does it? How do masses generate this propensity to attract each other? And at the end, there's some consideration of how this gravity affects possibly the expansion of the universe. There's another difference that I want to mention in between what I'm going to be doing here on my work on gravity and what happened in my special relativity work called Reconstructing Relativity. In that case, definitely the constructive model got to the Lorentz equations. No mismatch, everything perfectly aligned. And here, that's not going to happen. I'm not going to end up at the end of this series showing how Einstein's general relativity equation is correct. That's not going to happen. But largely because his gravity general relativity theory is so complex, I literally wouldn't know. I think some of the things that I will do are aligned with Einstein's thinking, and some of the results I think will be in agreement, but I don't have the mathematical chops to actually fully understand what his theory is or does. So I can't get there. But my concern is really trying to understand how gravity works, at least partially. And I think you'll be surprised that some of my models are amazingly good at representing how gravity works. And there, I had postulates for special relativity. There will be some new postulations. In special relativity, it was mostly about what is the nature of matter. We talked about energy, matter being composed of energy, traveling at the speed of light through space. Well, here we're going to have to make some new postulations about the nature of space itself. So it's going to be, in general, a bit more speculative than what special relativity was. Although I'm not going full tensor math, not at that level, but the math used here will eventually get to the use of calculus, which is a little more advanced. Certainly in special relativity, there was nothing other than trigonometry. And so here we'll get into calculus, but you don't necessarily need to know calculus to follow through most of my thinking here. Another thing is, although I did put some time into trying to figure it out, I still don't have an explanation of why that G that Newton used, and it's in Einstein's equations too, there's this gravitational constant, and I had hoped to be able to find some reason, some connection of that constant to other constants or some other known facts. Wasn't able to do that. Still no explanation of why big G is big G, but those guys didn't either. So that's still on the table. So you can see this is going to be a different kind of adventure than what special relativity was for me. But I still think there will be some very interesting things in here. And some other practical differences between what's going to happen here and what I did before in special relativity is less philosophical talk. That nature of truth thing was a special relativity topic. No similar topic here. You can expect things to roll out more slowly. Some of this work was done on old computers, and this is going to be a little bit archaeological. It's going to take me time to recover or reconstruct simulations and graphics, but there will definitely be simulations and graphics. I just have a feeling it'll all happen a little more slowly. Remember, my special relativity videos were kind of in parallel with a book, which was very much completed. And so I could go to that for text to read and so on. Well, here I have a text for this gravity, but it's not as completed. And certainly the graphics are not as well developed. Or I should say, not as well developed in advance. It's going to be development in real time as these videos roll out. As always, I really appreciate your support and your patience, and I'll appreciate that patience in advance this time. Please like and subscribe to these videos on YouTube, and watch my earlier videos on Special Relativity if you want to be ready for what's about to come. I also have a book on Amazon on Special Relativity. It's called Reconstructing Gravity. And I plan to continue to add music clips at the end of each video. But today it's going to be a little different. It's going to be not music, but kind of music to my ears as of July 20th, 1969. Thanks for watching. Catch you next time.
Forward. 60 seconds. Lights on. Down 2.5. Forward. Forward. That's 40 feet down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drifting to the right a little. 20, down 1/2. 30 seconds. Forward. Just. Good. Okay. Contact light. Okay, engine stop. APA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.